All right, number 7. We want to determine the graph of f prime from the graph of f. And so looking at this graph, we'll just kind of read off the slope and see what happens. So in this first section, it looks like we go down 1, 2, 3, and right 2. So down 3, right 2. So 3 over 2, 1/2, negative 1/2 for the first section. Then you have a corner point, so there's going to be a point of discontinuity. And then we have a slope of 1, so up 1, right 1. So we got a positive 1. Then we have another point of discontinuity. And then this slope looks like 1/2 down, down 2, right 1. So a slope of -2, not a half, -2. Then we have another point of discontinuity, and then another slope of 1. So we're going to find out which graph has those characteristics. So the first one was a -3 over 2, which is -1.5. So as I look at these graphs, I can definitely rule out B because the points of discontinuity will be jumps. A looks to be at a -1.5, and it jumps up to 1, and then looks like it goes back down to -2, and then back at 1. So A looks really good, so we're going to mark that one. This first one is at a +1.5, and we were at a negative. And then this one is also positive. So A is going to be the one that's going to best fit our derivative. All right, number 8, we have a couple parts here. We're going to use this graph and answer the following. So part A says find the values of x in the interval 0 to 5 where it's not continuous. Okay, so at 1 we have a break or jump, and then the rest of the graph is continuous. So remember in the text we talked about continuous and then differentiable. So this won't be differentiable, which it kind of looks like that's the next part. But only 1 is not continuous. And then we want to talk about points that are not differentiable. So if it's not continuous, it's not differentiable. And so we won't be differentiable at 1, and we will also not be differentiable at 3 because of the corner point.